Hi, this is Len Epp from Leanpub, and in this Leanpub podcast, I'll be interviewing Alex Lancaster. Alex is an evolutionary biologist, engineer, writer, and consultant based in Boston. He completed his doctorate in computational and genomic biology at Berkeley and has worked in R&D in the broadcasting and IT industries in the US and Australia, and he's also held research and faculty positions in academia, including a research position at the Whitehead Institute at MIT and a faculty position at Harvard Medical School. You can read his blog at biosysanalytics.com and follow him on Twitter at biosysanalytics. Along with his colleague Gordon Webster, Alex is co-author of the Leanpub book Python for the Life Sciences, a gentle introduction to Python for life scientists. The book serves as an excellent introduction to computer programming for biologists, including those who have never written a line of code. Along with the book, you also get copies of code samples that you can learn from and adapt to your own specific research. In this interview, we're going to talk about Alex's professional interests, his book, and his experience self-publishing through Leanpub. So thank you, Alex, for being on the Leanpub podcast.
Thanks, Len. Happy to be here.
I usually like to start these interviews by asking people for their origin story. So I know that you, from your bio, that you studied both physics and electrical engineering before you got into evolutionary biology. And I was wondering if you could talk a little bit about your path through all these disciplines and how you ended up at Berkeley.
Yeah. How long have you got?
As long as you want.
Yeah. So I started life thinking that I would be be an astrophysicist. Basically, it was kind of where I sort of was originally, when I was a undergrad. And actually, I spent about a week in a radio telescope down in Canberra in a while ago now, shall we say, another century. And realized that wasn't really going to be it for me for the rest of my life. Although astrophysics has changed a lot since, but there was a lot of sitting in very quiet, desolate places, sort of, poring over data, and it sort of sounds very glamorous on the outside, but the reality of the day-to-day just turned out it didn't really appeal to me. So I sort of was trying to figure out what to do. So I decided to finish my engineering degree, which I started with. But I was always interested in evolution from a very young age. I think when I picked up Richard Dawkins' The Blind Watchmaker, which was written sometime in the 80s. And I was just fascinated with the idea of these biomorphs, which were these little creatures that he had built evolutionary on a Mac. And it was nothing to do with real biology, but it was basically you could construct these creatures from this sort of very simple genetic code, and it sort of always stayed with me. So I always sort of followed along, thinking that I would, if I could get training in physics, then I could sort of move that over to biology at some point. And but I didn't want to go back to academia straight away, so. After I finished up at in my undergrad, I went and worked in the software industry for about 4 years. I really did start as a design engineer at the ABC, which is the Australian Broadcasting Corporation in Australia. It's like the equivalent of the BBC. In their R&D section for a while, and I sort of cut my teeth on coding, and I did a little bit of hardware stuff, but I sort of rapidly realized that software was where it was at, and the web was growing, and the sort of very early days. And so I basically sort of set myself around the world doing software contracts. And so I went to the UK for about a year in the mid-90s, worked in a little bit in the banking sector, a little bit in the telecommunications sector, sort of building my tool bag. But I always had this idea that at some point I'd come back and do grad school. And then sometime in the late 90s, I decided I stumbled across, I actually had knew about it before, this place called the Santa Fe Institute in New Mexico. And I could have been following what they've been doing out there. And they sort of really on the cutting edge of, complex systems and biology and all that stuff. And I thought, well, I should somehow get myself a job there. So I ended up downloading, I think, a very early version of the Swarm software in the late 90s, and sort of, basically playing around with it. And I ended up moonlighting while I was working in a bank on their website, building these models, computational neuroscience models with some folks that I knew in Australia, or that I'd sort of found in Australia. And back then it wasn't as easy to find collaborators then, so I sort of had to go to conferences and chase down physical papers and stacks and stuff like that. And so I kind of helped build a bunch of models for those folks. And in doing that, I learned this software package called Swarm, and then it turned out there were a couple of job openings. So I applied and I got it. And so I found myself in Santa Fe, New Mexico in '97, not knowing a soul, wondering quite why I had gone there. And I was sort of part-time in a PhD program at UNM, University of New Mexico in Albuquerque. And I was doing that for a while, trying to do it part-time, but I was really having a lot more fun at the job, working at the institute. So basically they hired me as one of their software developers. And I was sort of able to work with a lot of researchers, and that sort of solidified my interest in biology, basically, and sort of moving back towards the evolution side of things. And so I ended up, basically postponing my program, and then I reapplied, ended up going to Berkeley and studying population genetics and theoretical models of biology for grad school, and then moved into all the way along, interested in sort of keeping up my software skills. So I always had sort of a foot on the computational side and a foot in the biology. Then, I sort of ended up doing the sort of standard academic track of doing a postdoc, did a couple of postdocs. And then I was faculty at medical school briefly for a couple of years. And I just decided that the way, well, a lot of things have happened since I moved here, but one of the things that happened in academia, as you may know, it's that it's become a very sort of tough environment to do kind of more out there research. And in the way that I see academia going in the last probably a while now, but it's really accelerated in the years since the crash, I think. So I decided that it would be more interesting to try my hand at sort of some kind of sort of hybrid career. And then at some point, Gordon and I met, and we sort of kicked around this idea of creating this company, and we really got going about a year ago, and that's what brought us to Amber Biology. So that's probably a overly long-winded answer to a shorter question, but that sort of takes us right up to the present. But I'm happy to go back into any of the sort of eddies that you found interesting there. But that's sort of that's how I kind of got here.
Yeah, that's a really great answer. Thanks very much for that. I mean, I've had a bit of a, in conventional terms, I suppose, meandering career myself. So it's really interesting to hear about, or to hear from someone who, follows their curiosity where it takes them, which is, it sounds like, what's motivated you.
Pretty much. I've never been very good. I've never been one for really great sort of mapped out career plans. And in a funny kind of way, I think the way things are moving now, the sort of that notion of the career plan is becoming somehow less relevant. But that's something we can definitely talk about if you want. But
yeah, well, I mean, I have a doctorate myself in English, not in biology, but I could talk about academia and things that have been happening there.
Oh yeah, I'd love to hear your experiences on that
forever. But yeah, actually, I was wondering, when it comes to academia and the sciences, this is a topic that one sees in the news recently about the difficulty that young scientists have getting tenure, and the importance that's placed on getting published, regardless of necessarily the kind of relevance of the publication. Is this something that you've had kind of direct experience with?
Yeah, and I would say that it's more than just the people getting tenure; it's people getting the tenure track positions in the first place. So that's there's the bottleneck is I think even greater there. Yeah, and you have a lot of very highly trained, highly motivated, highly trained people who are competing for a very, very limited number of slots, and those slots are certainly not. They're certainly not increasing, and if anything, they're probably decreasing because universities are basically oftentimes cutting their budget, and they're often looking to, supplement their, the people that they do bring on. I think, it's one of these things that it can be overstated, but I certainly think that at the level of sort of the higher administrations, there is definitely a push towards finding sort of faculty and research areas that are sort of highly fundable, because a lot of the costs of running university have been sort of shifted toward federal grant money, especially in the United States, and so that puts a lot of pressure on those administrators, and that kind of gets translated down to the department. Now, I think kind of the department levels, it's probably the picture is a bit more mixed, because I think that most people there, really want to hire people that are, doing interesting things. And I think that in general, most people want to do the right thing and, are interested in sort of intellectual balance and sort of the usual things that, that academia is sort of known for, but they find themselves under a lot of pressure. So I think that sort of that combination, and there's sort of, it's sort of a system. It's sort of the pressure to publish in prestigious journals sort of has and how they're ranked in terms of grants has a tendency to sort of, factor into the grant making decisions. And so that feeds back to the faculty. So it's kind of there's a sort of a set of interlocking factors, you might say, that drive the system towards, sort of a setup where, you want to minimize risk and maximize return. And so that sort of militates against people doing sort of more unconventional and risky approaches. And it also militates against doing smaller scale and sort of actually cheaper research, which is sort of a strange thing, because, oftentimes these like little side rivulets can be the things that can actually drive science forward. And you really don't know where the next big discovery is going to come from. So yeah, definitely the publishing part it's part of a larger network of problems, but it's definitely a big driver.
Yeah, it's really fascinating to me to watch in North America what I call admin creep, like mission creep, but admin creep happening at universities where, tuition costs are rising and rising. The cost of running a university is increasing, and yet there's this budgetary pressure on professors,
right,
and scientists,
right,
and people doing research, and so costs are going up, and yet there's this squeeze. And
no, absolutely, and in fact, yeah, we pretty much talking about this for almost a full day on Saturday, at the Ronan Institute's first unconference. I don't know if you might have seen that on my blog. But,
no, I didn't see that, but I know what an unconference is. Actually, if you wanted to describe that would be good, I think.
Yeah. So the unconference, I'd actually never done one myself before, but it was pretty cool. The idea is that the sort of the theme, the sort of the topics and the areas that get discussed and the talks are effectively sort of self-organized by the participants. And the way that that they did it on Saturday, and I was sort of loosely involved in organizing it, is that there were three sort of seed speakers at the beginning. They spoke for about 10 minutes each, and then sort of that generated sort of a list of things in people's heads, and people would write down, on a piece of paper, like a topic they'd like to discuss, and then you put those pieces of paper around the room, and then sort of people walk around and identify the things they'd like to discuss, and then we sort of, propose topics that were sort of similar, you kind of merge, and then sort of out of that, we got about three distinct groups. And they talk for, we have a discussion for about an hour and a half, I think, or an hour or so. Really interesting group of people. And then we sort of break for lunch and then sort of repeat the afternoon and then sort of summarize it at the end. And it makes it a really interactive kind of format, as opposed to a traditional conference where everybody's like sort of like half paying attention and on their laptops and that kind of stuff. So, and it was sort of perfect for the kind of thing that we were trying to do, which was to really generate a kind of robust discussion around the future of sort of scholarship in general, and not just in the sciences but in the humanities as well. Like to try and think about ways that we could do things that don't necessarily involve the traditional kind of institutions that we're used to. So that was sort of the big, and that was great because we got people, as I said, people from like theology and English literature, and people from a lot of biologists were represented there because they tend to be overrepresented in the Boston area. But yeah, so that was really interesting.
Yeah, that is really interesting. Do you feel that there's a pressure building to push people to a model of education that's not university based?
Yeah, that's an interesting question. It's not. I don't know if that may happen, or I mean, I think there's certainly room for a lot of different paths to gaining knowledge that don't involve going through the sort of ivory tower. I think there's sort of a realization. I kind of get the sense that sort of realization that like if when you get a scarcity of positions or scarcity of sort of what's the right word I'm trying to think of, this basically a scarcity of sort of educational goods, shall we say, so everyone's focused on getting into sort of top colleges so they get top jobs and so on. And I think what happens is that people attach a sort of monetary value to that luxury good, and then oftentimes that becomes the goal rather than the education. But I always sort of assumed for many years that was sort of a byproduct. There should just be a byproduct of getting education, and but I do think there's a lot of pressure to getting sort of it's sort of credentialism, I call it, and I mean, yeah, I don't want to be the pot calling the kettle black, because I played that game too, but I kind of realize the limitations of that sort of thinking, and so I do think there's kind of a realization that maybe like having everyone go to college in the sort of standard way won't necessarily work for everybody and may not be desirable in all cases, especially with the student loan thing. That's the scary. I feel like that's the next bubble. That's the next kind of scary bubble that people haven't really confronted. Is the sort of student loan crisis in the United States, because if everybody's told they have to get this kind of education, but then they go through life saddled with all this debt that they always feel they need to get the kind of job that can support that debt, then that sort of cuts down on the career options that people can pursue.
Yeah, and even very crucially, one of the I guess interesting aspects of student loan debt in the States, which is over $1 trillion and greater than credit card debt, is that you can't
go bankrupt.
You can't go bankrupt. It's incredible. I was listening to a podcast interview by Ezra Klein with Joseph Stiglitz recently, the Nobel Prize winning economist, and he was saying two of the most sort of consequential decisions that the United States made in the last 20 or so years is one was that if a company went bankrupt, rather than the people working for it having the primary claim upon the assets, it was people who held derivatives
right
in the company. And the second one was that even if you go bankrupt as a student, you can't clear your debts, and this can happen. It can happen where if there's a student debt that's associated with a parent, the child can actually die before completing the degree. And if the parents go bankrupt, they can't clear the debt. It's very perverse. And when you add into that the importance that's placed on the rank of the university that you've attended, it becomes very, and when you think about the pressures that are on someone who's 17 or 18, if you don't get into one of these universities at this age, you can still get ahead in life, but you feel like you're behind, and you will be, in a sense, in the conversation, behind your whole life. You really will be,
Right.
if you don't get on that track, if you don't go to Berkeley or Harvard or something like that. And the pressures are extremely intense. One of the topics that comes up on this podcast, just because of the type of people that often publish Leanpub books, is should you, if you want to become a computer programmer or software engineer or developer, should you go to university in 2016?
Right.
And I was wondering what your opinion is about that very specific question. If your goal is not to get an education, not to become an educated person, but to be a developer and work, do you think that people should get, in the States, should get university degrees in computer science?
Yeah, that's a good question. My sense is not if that's just the one thing you want to do. Like if that's, that's the one thing you want to do, and that you can educate yourself in the other areas in other ways, then I'd say that probably, yeah, that isn't or at least it shouldn't be a necessity. I mean, I do think that it's kind of silly to force people into, I feel like in the sort of the more general answer to that is almost to say that, like we sort of got we still got a kind of a one size fits all system that doesn't really take into account the sort of nature of people's individual, quirky, career paths. There's sort of an expectation that there's a set of norms that you follow. And if you're off those norms, then you're kind of like probably a little bit weird, and, you're probably some kind of, person who's failed, which is, it's kind of weird because on the same time we laud all the college dropouts like Bill Gates and Mark Zuckerberg for starting all those things. But at the same time, they're kind of the exception that proves the rule a little bit. I feel like in general, like I would say also, I growing up in Australia, I never felt that same pressure in the same way. Partly because the culture is different. Now things have changed a lot in, the 20 or 25 years since I was undergrad, but there was never a feeling that, like that there was always options if you really wanted to do those super professional things, but, there was a sense that you could get ahead if you in a school, or maybe you did just you didn't go to grad school. You went and did you went to college, but you didn't really necessarily want to build a career in that whatever thing that you studied, but it was sort of a period of your life, and it didn't define you in the same way that I feel that it kind of defines people here. Or at least it feels like they feel like they're defined by that experience. And that's just, that's a part of a cultural difference. And also the fact that we do have student loans, but they work totally differently. So I feel like there's that's a long-winded answer, but yeah, I would like to see a world in which that we didn't sort of push people into career paths that, for which they're, they don't want or aren't really necessity, and just a general openness to people finding a different way to whatever their passion is. Because I feel like ultimately that's the thing that matters, and that's the thing that's going to make people productive members of society, is not to say you have to do it this way, but figure out ways to support what they do, rather than sort of predefine it for them and sort of map it out, because things are changing so fast anyway that I feel like almost any career advice these days is going to be 5 years out of date.
And where did you grow up in Australia?
I grew up in Sydney.
Okay.
Yeah, so in the suburbs of Sydney, so that's and I was there until the late 90s, I went to the UK and I came back, so I bounced around before coming to the United States. But I would say that
you did the walkabout.
I did the walkabout. Yes. And we're sort of known for that, for being, we tend to go overseas and then sort of come back. And
Yeah, when I was living in London, I had I always had an Australian roommate, which meant I always had at least three Australian roommates.
Yeah.
Because people would always be visiting, including parents on the couch for 2 weeks, kind of thing.
Right. Right.
But I saw who was it? Paul Rudd, not Paul Rudd.
Kevin Rudd.
Kevin Rudd.
Yes.
Talk. I worked for Macquarie Bank for a couple of years in London.
Oh, really? I worked for Macquarie Bank for about 6 months.
Oh, no kidding.
Yes.
At One Ropemaker Street.
One down in right down on right in the right in the stock exchange there in Sydney.
Yeah. Oh, in Sydney. Yeah. Oh, in Sydney. Oh, you worked.
Yeah, Sydney.
So I worked,
yeah.
Oh, pardon me. I worked for them in London.
Right.
But I had my training in Sydney. Yeah, that's funny.
I worked on their first website ever.
Oh, really?
Yes. Yeah.
Oh,
so
wow.
I was in the team that helped build the first Macquarie Bank website. It was about 96, I think.
That's fantastic.
Writing Perl objects and stuff like that. Yeah, it was an interesting learning experience too. I realized the banks weren't really my future at that point.
Yeah, I realized that after 2.5 years. It took me a bit longer, but it was an exciting experience, especially working for an Australian bank trying to make its way in London.
Right.
It was quite curious.
Which side of the banking part were you on?
Investment banking. So I was doing mergers and acquisitions. It was pretty interesting.
Right.
In fact, actually, quite a few of my colleagues, one of the curious and I thought great things about working for Macquarie was that people weren't. There were fewer business school graduates than you might get at other investment banks.
That's interesting.
People were, for example, one of my colleagues who was brilliant had done maths and had gone to London on a holiday. The job he got was being an investment banker for Macquarie Bank.
Wow.
Or Macquarie Group, as it came to be known. And
right.
But there were a lot of people from a chemist from Perth, and people from all over, from all kinds of different backgrounds. And it was really this was in the mid 2000s, and it was a really interesting time.
Yeah.
I'm sure things have developed a lot since then.
Yeah.
I wanted to ask you about Swarm. It was one of the first open source agent-based modeling tools. And I was wondering if you could talk a little bit for people who might not know what those are, what that is and why Swarm was important.
Yeah. Well, Swarm came out of originally from folks sort of before my time at the Santa Fe Institute in New Mexico. And there were sort of, for those who don't know, but it's basically a sort of, I sometimes call it a think tank. They like to use that term. It's a small private nonprofit research institute that's dedicated to the sort of what they call the science of complex systems. And that sort of, in practice, means people building computational and mathematical models of all kinds of systems, from natural systems like biological systems through to models of the economy, and even to things like archaeology. And so the sort of one of the sort of, I guess you might think of it as a sort of set of language primitives that a lot of these models are built in, as sort of in the language of agents, where rather than like a lot of typical mathematical models where you sort of have an equation that describes sort of the aggregate behavior of a bunch of individual using, say, differential equations and things like that. You build models where you represent the actual individuals as code, and the sort of natural representation is, in computer science terms, is that of an object. And so there was basically a push that people basically found they were basically building code structures that were almost identical to each other, And then there was a realization that, well, maybe we should have sort of a common platform that we could, reuse, and then sort of build our sort of domain specific stuff on top. So you'd have a library that you would then write your code for your model in, that would call functions from that library. And that's basically how Swarm came about in the mid 90s. And it went through number of iterations. I wasn't involved in the prototype. I came into the project a little later. And we were sort of at the point then where we were sort of now interacting. So my job was actually kind of interacting with the scientists at the institute and visiting people to sort of talk about the science and think about how we could like translate that science into the model, and then sort of work with the other people building the kernel to sort of, create the right infrastructure. So it's kind of like a bit of a translator between a lot of different disciplines to try and sort of figure out, okay, how do we sort of represent these things that would work for the largest number of people and the largest number of kinds of scientists, and then sort of also figure out like at what level, what abstractions you would want to use that'll be generally useful, and what abstractions are kind of like very specific, say economics or sociology or things like that. But yeah, the sort of fundamental notion is that you have a bunch of individuals that all interact, and they have sort of rules, and they have state, and you sort of, it's like Sim City or something. You set the things up, and you sort of let the thing go, and you see what happens. And that's sort of like so Swarm was the first kind of toolkit to do that, and it's sort of, it's inspired, several others. And there's still the Swarmfest meeting is still that we started back in the late 90s is still going strong. It's been going for about 20 years, and I hadn't been for 10 years, and I went again for the first time in many years, 10 or 11 years, 2 years ago. And, it's sort of great to see that the community is still sort of, out there trying to sort of push the boundaries because it's still, in some sense, it's still kind of a little bit on the edge. I'm surprised that it's not more mainstream, actually.
And why do you think it's not more mainstream than it is?
I think that probably because models are complicated, and it's harder to. I think there was probably some early overselling that this happens a lot in areas of science that are where everyone's very excited. They start making promises that they probably can't deliver. So there's a little bit of a backlash to sort of complex systems approaches in general, and agent-based modeling is one of them. So I think that had some role. They are more complicated to analyze than just traditional models. You don't have the same set of toolkits you can use to do like sensitivity analysis that you can. And I think, yeah, it sort of dovetails a little bit with sort of the problems of academia in general. There's just not as much. I feel like there was more appetite in the late 90s to just try new stuff in general in science. And it could just be that I'm getting older, or it could so it may not be maybe in my head, but my sense is that, that's still considered it's harder to do stuff that's kind of a little on the edge now. People really want to see some return on investment, whatever that means in science, which, I think is unfortunate, because I still think that, I think it's important for people doing stuff. It's important to do stuff that doesn't always work and might fail, because because it hasn't worked yet doesn't mean it will never work.
Yeah, it's interesting that the theme of sort of stress in academia is coming up, because it's something I think about a lot. I mean, Einstein goes for a walk and sees a workman on a scaffold, and imagines him falling down, and has a great insight that sort of changes the world. And how do you can't possibly quantify Einstein going for a walk.
Right.
And,
right.
I mean, there was something that happened a few years ago in the UK called the research assessment exercise, where basically an incredible amount of professors' time was wasted in assessment of work, under the futile illusion that you can quantify research.
Right. Right.
And you end up with the people who should be doing the kind of forward thinking subordinated to,
Yeah.
to put it crudely, politicians who are trying to make a point to people who are skeptical about higher education fundamentally.
Right.
And it's very, you know, cart before the horse kind of stuff.
Yeah. No, I agree with that.
And well, actually, that's probably a bad metaphor. It's kind of like, people who really don't have an appreciation for what happens at higher levels of research being skeptical about it because they don't see progress. And you need to give people the time to have the revelation in the shower, and to pursue paths that may actually ultimately be fruitless, because that's what cutting edge thinking is. I was actually wondering, what was the work you did for your thesis, for your doctoral thesis, back in the day?
Oh, yeah. So I was working in, so I kind of switched gears a little bit away from the purely Asian-based stuff, and I was working in immunogenetics or immune system genes. So I was actually looking. It was actually fairly empirical. I was sort of looking at all these data sets coming from different populations around the world where they would go up and genotype them for these set of genes called HLA genes, so human leukocyte antigen. They're basically involved in the immune system, and they're the things that help detect, like when you have a bad, pathogen that's invaded your body. And one of the questions that have puzzled evolutionary biologists and people who study population genetics is like why this region of the human genome is incredibly polymorphic. Why are there so many alleles, different variants? And so I was sort of working on sort of trying to quantify that nature of that variation, and then building sort of tools to analyze it, and sort of see if we could like basically measure the strength of selection on at the level not just the whole gene itself, but also at the level of like the individual residues of amino acids and the actual three-dimensional structure of this molecule. So yeah, I'm going off on a tangent here, but yeah, it's sort of effectively trying to sort of figure out if we could use the sort of population data to get at sort of functional questions about how evolution has shaped the sort of nature of these molecules. And so there was some statistical analysis and a fair amount of coding. So I built a sort of pipeline for that that's still used today called PyPop, Python for Population Genetics, and also sort of developing sort of statistical methodology for figuring out like how to use like things like Monte Carlo Markov chain stuff to sort of to better analyze this data. So that was sort of, yeah. So it's basically on that sort of interface. That's really quite sort of classic computational biology meets evolutionary biology. It's kind of where I was at. And I've still got colleagues and projects that, that'll probably see the light of day eventually. But it really got me interested in the sort of, it sort of cut my teeth on learning one specific biological system really in a lot of detail. Because the danger with the complex system stuff is great, but you can often find yourself, going off into abstract speculation. So I feel like, even though it's not really what I still do on a day-to-day basis, I still think it was a valuable for someone like me who I always like to be trying new things. It's good to sort of have deep training in one area. I think of it like the fox and the hedgehog,
Mm-hmm.
if you've heard that analogy.
Yeah.
Which is why I call one of my blogs the Curious Foxhog, because it's like I sort of feel like it's good to have a deep training in one area, but at the same time, it's good not to get too tunnel vision. So yeah, that was sort of where I came in on that stuff.
And is that related to evolutionary systems biology, which I've read you're involved in, or is that something different?
Yeah, I mean, it's part of it. After I left my grad program, I started working in models of vulnerability, but specifically related to prions. And it turns out that prions are this interesting mechanism for storing variation that can be released when organisms are under stress. And so it's kind of a fascinating, and I think of that as sort of a classic example of sort of evolutionary systems biology, because the systems biology, as I kind of think of it, as kind of like the mechanisms and the sort of, the networks that, are ultimately sculpted by evolution. And that's kind of like, I think that's the kind of ultimately, that people are trying to integrate sort of evolution for a long time was very, the evolutionary theory is very abstract, and it didn't refer to anything like, any sort of real systems. Just they would have these models about consider a locus with two alleles and play around with it. But now we have a lot more data, and we can say things like, well, we know this trait is generated by these networks. What are the different evolutionary paths that you might take, does the system take? And so that's kind of what I think of as evolution system biology. But my PhD it didn't really exist even as a discipline. But it was sort of the training I needed to get into that area later.
And actually, this is kind of a selfish question because it's a preoccupation of mine. But what do you think about evolutionary psychology?
I don't really think about it a lot. I used to read a lot about it back in the day. I'm a little bit skeptical of it in general. Just I'm always a little bit skeptical of explanations that involve sort of predefining our notion of what's fit in the environment. And I think the problem, as I see with sort of evolutionary psychology, or some of it anyway, is the fact that it tends to sort of overestimate the role of things like, competition and, the survival of the fittest kind of side of evolution, whereas evolution as a whole includes all kinds of not just, competitive processes, but cooperative processes and symbiosis and mutualisms and all these kind of rich dynamics that I kind of feel that at least some of the evolutionary psychology stuff is a little on the simplistic side. And it also sort of, it also interfaces with sort of these arguments that come from more from the political and economic side that kind of can easily be used to sort of justify sort of the existing sort of power structure, or to say, oh, well, this is, there's always a danger when you go into nature and say, oh, look, it's done this in nature, so, it must be, that must be right or somehow, or, you know what I mean? Like that's my sort of main problem with some of the evolutionary psychology. Having said that, I don't have a problem in principle with studying, like, using evolutionary principles for, in all kinds of areas in economics and psychology. I think I really like the stuff that David Sloan Wilson works on, which is kind of integrating economics and evolutionary thinking, complexity thinking. I've been reading his Evonomics blog quite a bit lately, and that involves psychology, but So as far as the sort of classic evolutionary psychology stuff, I haven't looked at it in a while, but I felt like at least the version of it in the 90s, early 2000s, was always a little bit iffy to me.
Yeah, the fundamental question I have about it is, how do you do experiments?
Right.
If you can't do experiments, it's not science, and it seems, to put it crudely,
right. Right.
And so you see things like, for some reason, the former, I think probably now former editor of the science and technology section of The Economist loved evolutionary science kind of just so stories, and you see this in this sort of science press generally, but things like, I think they actually did this and mentioned this in The Economist once, but they said that they've proven that women have a preference for pink, and that this is cross-cultural, and that it's probably because when in the olden times, in the long ago, that women had to search for berries, and so they
Right.
were selected for the experiencing pleasure when seeing color in nature, and this was in like the 2000s, like this wasn't
Right.
in like 1810, this was in like 2010.
Right. Right.
And
Yeah.
it just seems like the stuff that surfaces obviously in the press is going to tend towards nonsense.
Yeah.
But how can one possibly run experiments on human psychological evolution?
Right. Right. Yeah. No, that would be my problem with it too. It just, yeah, the just so nature of it is, like, yeah, that it rears its head in those circumstances. And yeah, and the danger is because they can easily reinforce people's sort of preconceptions and scientize something that really shouldn't be scientized. If to coin a term.
Yeah, that's a great word.
um,
Yeah, on the subject of science and programming, which is what your book is about, I wanted to ask you, how important is it for scientists these days to learn how to program?
I think it's I think it's pretty important, especially especially as you get in the more quantitative disciplines like you know like the life sciences are becoming rapidly. But I also don't think that one should sort of assume that that's the only thing you need, and that everything should be that you should sort of drop your pipettes and and just do coding. Although I have done pipetting once, but I know that I'm never going to be a great bench biologist. But I think getting your head around going a little bit beyond spreadsheets, and I mean we say this in the book blurb, is going to be really important. And it's interesting actually. Especially with the Swarm Fest, I'm meeting a lot of people who are not even scientists, who are like the digital humanities people are really kind of picking up on the programming side of it too. And there's all and so yeah, I think it's important. I think also you have to sort of simultaneously keep in mind that programming is ultimately still just a hammer, and you don't want to make everything a nail. So I do the sort of flip side of like on one hand I'm like, yeah, we should definitely, people should get used to computational and quantitative thinking and all that good stuff. But at the same time, we shouldn't sort of get rid of people who work in museums and that just love you know collecting specimens, or like there's room for all of those skills and people. And I sort of, so I get a little bit nervous when people say, well, everyone needs to learn to code because that's what everyone is going to be coding in the future. I don't think that's true. Having said that, like I think another reason to code for everybody, and scientists in general, is that it's good to know just the thinking, because a lot of the systems that you'll be interacting with are going to be engineered, which means kind of knowing the fact that there's code behind that. What does that actually mean, and what the limitations are, just to sort of be a generally scientifically literate citizen. I like it. There's a great book by Douglas Rushkoff called "Program or Be Programmed." I don't know if you saw that. It's really small. Really, I always give it to people who sort of wonder about programming, because he has a good spiel about, like, yes, you should probably code, but you don't have to, but you should definitely know what's involved, as this becomes more part of your world, kind of thing. So yeah, so I think my position is kind of maybe a little bit more nuanced than you might expect, just because I also realize the limitations of the sort of data driven, metric obsessed kind of thing that we often can get ourselves into. But at the same time, I feel like it's good to know those things, know how to analyze and use code, even if you don't do it as your full-time job, if for no other reason that then like what's going on behind the scenes, kind of thing, and how code is being deployed. So I think from that perspective, I think yes, people should learn to code, even if it's not their only thing.
And my last question is, why did you decide to publish your book on Leanpub? I should say, by the way, Python for the Life Sciences is a really great book. A ton of work went into it. It's really well done.
Oh,
Yeah, I mean that I see a lot of books.
yeah,
And
yeah.
it's really good. And yeah, I was wondering why you chose to publish it with us.
Yeah, well, kind of we kicked around a lot of different things there when we started our consulting firm, and one of the things that Gordon and I both agree on is like we don't love gatekeepers, and we love the idea of people sort of doing things from the bottom up, and so we looked at thought about like approaching a publisher and proposing it, but we just felt that's going to add a lot of you know stuff in front of us, and let's just write the damn thing and see where it lands. And then when we sort of started looking around, actually a friend of mine on a Slack channel that I recommend, he's always got cool things he writes a lot of cool things about programming and science and complex systems. And his name is Bill Tozier. Vagary.com is his website. He just mentioned it in passing, and I was like, oh, I should check this thing out. And I went over there and I said, this is really interesting. And so, yeah, we sort of, so we were sort of initially thinking, oh, well, we'll just sort of put it up and see what happens. And, we really thought that it would be, it sort of fit our sort of general ethos. And obviously you have a really great, sort of revenue model, which I think is really good. And, to be honest, like looking at the way Amazon works and these big e-publishers, they started to act more like rentier type, models.
Like
And
what?
so
Like what? Sorry.
like sort of more like, they're sort of monopolizing the market now. And so
Uh,
they're sort of able to set them, they're being like able to set the monopoly prices.
mm-hmm.
And I would rather support in general, like, new emerging businesses and organizations that are sort of, trying to, make a way to, you know, uh, make a living without necessarily having to create a, massive infrastructure. And so, yeah, that's kind of why Leanpub and self-publishing seems the way to go. And that said, if a major publisher was to pick us up tomorrow, I guess we could continue doing both. But I would, yeah, I think that, I like that idea of, I think it's really important to, um, like, I like to say, like, for example, with our, consultancy, we're trying to sort of build a sustainable business. We don't necessarily want it to be, we don't want to be taking over the world. We're not after world domination. We're out to sort of, you know, earn enough money to keep paying the bills so that we can do the cool science or research or art or whatever it is that we're doing, not just, you know what I mean? So that's kind of like that was sort of part of it. That, I like it when I see other people doing, I feel like it's good if I see other people doing cool new things. I'm always like, I want to support that thing rather than like, even if it means like, okay, I don't get like the massive return in the immediate, I feel like it's better to, in the long run, we'll all be better if we kind of do that. That's a
Yeah.
sort of, yeah.
Yeah, thanks. That's a really, really great answer. One of the things, I mean, in many ways, your book is kind of the classic Leanpub book, and I mean in the sense the book that we love to see because it's I think well, both your minimum and your suggested price is $34.99, and it's 304 pages. And if you're in the life sciences or a biologist and you're looking to learn to code, I mean, this is a book you get great value from. Definitely worth $35.
Yeah, we think so too.
Yeah, and I mean definitely. And one of the interesting things that sort of we're still learning about this new model of self-publishing, but Amazon decreases the royalty rate that it pays when you go over $9.99 for a
Yeah,
book.
yeah, we noticed that too. Yeah,
Yeah, I mean from 70 to 30%, right? So
yeah,
they're basically saying all ebooks are interchangeable, and the price should be less than $10.
right, right, exactly. They drive you towards that.
Yeah, and I mean I think that that's probably an appropriate price point for novels.
Hmm.
And I still think if you are writing a novel, you should have it on Leanpub as well because you will make more money because it's 90% royalty. But
Yeah,
if your book is worth more than $9.99, and I don't just mean that because the price is more than $9.99, if it's actually worth more than $9.99, you should not be publishing in a place that's meant for novels.
yeah, right,
Books like yours, books like so many other Leanpub books are actually can like change. Well, I mean, not specifically your book, but like for other types of books, they can change the amount you can charge people for the work that you do
right,
because you've learned
right,
something new and you've got skills that you didn't have before. They can help
right,
increase the skill level that you have, and something
right,
like that people are willing to pay more for, and authors should earn more from, I think.
right.
Um,
Yeah, and it was basically a little under a year. I mean, not full time. Wasn't like 40 hours a week, 7 days, 24/7 type thing. But we put a fair amount of, and the other reason I liked it was that the way we did it was that because we had the freedom to do it at the kind of pace we wanted, we could sort of write the book that we wanted to write, not necessarily the book that sort of someone else had kind of like decided like fit the right market niche. So we could sort of take our time and make it a little bit lighter and put in jokes and things like that that might not have passed muster or may not have fit into, I don't know, some other publisher's kind of conception of what they wanted. So we like the idea of having a book that has a bit of personality. Because tech books can be kind of on the dry side. So um, that was another nice thing about it, and also the iterative nature of it, because it also goes with the whole software development philosophy that we kind of use in our own consulting. The sort of agile type thing of like release it, get feedback, improve. I feel like that's a really good model to, and we didn't fully embrace it, like we didn't do chapter by chapter, but we're certainly going to upload new versions, and so I feel like that approach is really, and I think it's still pretty new for the book publishing world still, I think, and but you see how effective it is in software at at getting better sort of um, more robust if it's done properly, of course, kind of result. So that was another thing that was kind of like cool about the Leanpub thing, was that like that I like that. I like that idea that you get something out. I feel like in general, doing anything creative or anything new, get something out there. It's not perfect, improve it, do it in public, improve it, get better. I'm taking, I'm learning this just myself by taking improv classes. The same kind of thing. Like you're not that great at the beginning, but you perform when you get in front of an audience, you get better. So it's kind of a bit like that. I mean, just like sort of like not taking the risk, exposing yourself. People might not like every little bit of it, but that's okay. You get better at it. So I feel like, yeah, that it fits with that sort of philosophy.
Just before we go, I feel like I would be remiss if I didn't ask someone living in the United States the day before the big election. What's the mood like in? Well, you're in Arlington, Massachusetts. You were saying before we started this interview, just north of Boston, I think. What's the mood like down there?
In the greater Boston area.
Yeah.
I think I wanted to maybe of sort of, what's the thing, acceptance, grievance, with the stages of grief. Um, I'm, like I feel like we're at sort of acceptance phase now, with just in the sense of like whatever will be will be. With everyone's just so over it. So much, so many. I don't know. I can't I can't read any more editorials. I can't read 538.com. I can't, it's like I just like I feel like almost everything has been said that is going to be said, and it's just going to be up to the voters now. Um, but yeah, people are concerned. Obviously, I think that yeah, I think definitely in our community, because we're around a lot of like academics and scientists and people with sort of what the results will be for all of that. So that's something that I think that definitely comes up when we're in conversations with friends and colleagues.
Yeah, well, thanks very much for that. That's very well said, and it'll be an interesting artifact because this will come out after people know the
Yeah,
results.
what the result was. Yeah,
um,
well, may I ask you what what's the view from Canada?
um, I could talk about that for a long time, I suppose. Uh, I think that probably most Canadians are quite concerned that Donald Trump could win, to put it
Right.
straightforwardly.
Yep.
Um, uh, Canada's a more complicated place than Canadians pretend it is.
Hmm.
But the spectacle over the last like 2 years of the campaign of our we have one border, right?
Right.
And it's with the United States, and to see someone who appears to be driven by no sense of responsibility and not constrained by reason, um, within a hair's breadth of being the president of the United States is something that I think people are concerned by. I mean, I think that, knock on wood, when this comes out, we'll all know. But
Yeah. Well,
I think,
hopefully, we will be able to breathe that sigh of relief. And
yeah, I think people here are like, in a sense, complacent. I mean, we just kind of take it for granted that Americans will make the reasonable choice.
right.
To speak on behalf of all sorts of people who disagree with me and generalize dramatically, but like, um, uh, it's we're watching. We're always watching what's happening in the
Yep.
states, but we're definitely watching now. I'm just getting a memory of uh, when I stayed up late in 2000 to make sure that Al Gore won Florida before going to bed, and woke up to a different world. Um,
Yes. Yes. And I remember that election well. I was only been in the States for a few years at that point, and that's when I started paying attention to politics. I think that a lot of people had. I think it's true. It's again a massive generalization to say that academics and researchers tend to try and go about their business to pretend that like nothing's affect them, or it's like it's above them, or they want to talk about them. But I think this election has certainly made people sit up and pay real attention because um, even in the other elections of other presidents, candidates, there's sort of a general agreement that, probably the NIH would continue and NSF always fun. They're not about to abolish them, but, sort of all bets are off with Trump. And I think that's what makes people really scared because it's like, really don't know. It's like a lot of the things that you take for granted just could not be true anymore.
Yeah, I
And
hadn't
it's
actually thought about that, but that's the National Institutes of Health
health, yeah,
and the National
that's
Science
science
Foundation,
foundation,
and I hadn't thought
right?
about that. But
Yeah, no,
yeah, well, thanks very much, Alex. I guess
yeah. On
we'll
that
yeah,
cheery note.
on that cheery note. But yeah, thanks very much for taking the time to do this really fun interview. And thanks for publishing your book on Leanpub.
Oh, you are most welcome. It's been really fun.
Thanks.